Hi, here we have a question about scaling volume, area, and length. It's talking about a model aeroplane and it's comparing that with a real aeroplane. It could be talking about any two similar shapes, but they like talking about model vehicles and things. Now, we're dealing with these three quantities, and there's a relationship between the model version and the real version. But you must remember that the relationship is not the same for every row. I'll go into a bit more detail later, but let's start with the area row. I know that one. It's given both the data points. So I've got 18 centimeters squared and 2.88 meters squared. And if I do a bit of investigation, I'm looking for a kind of a nice number, really. And as it happens, 2.88 divided by 18 gives me 0.16, which isn't bad. So that's telling me that I times by 0.16. Now, the length is not going to be times by 0.16. It's going to be times by the square root of the area, which happens to be 0.4. So this one is times 0.4. And the volume is the cube of the length. Zero 0.4 cubed. So that's 0.064. So the volume is times 0.064. And from that, I can work out the missing numbers. Once you've got the ratios, it's all there. But you've got to make sure that the ratios follow that pattern. The area ratio is the square of the length, and the volume ratio is the cube. So just doing the length now, I could do 8 divided by 0.4. That gives me 20. And 38 times 0.064. And that gives me 2.432 in there.